Welcome friends. Let's do next episode number 10 of vectors. So if you have been attending the previous lectures, which I call them as episodes 1 to 9, you will be able to understand what we are doing now in the class. So we had done the introduction of vectors and we described various kind of vectors, how to add, subtract and how to multiply a vector by a number. Then how vectors are expressed in terms of I, j and k. So we have been doing these questions for last 4 episodes now. So episode number 6, 7, 8 and 9 we had been doing an assignment called practice paper 1, in which there are 22 questions. We have already done 21 questions. So the link of this assignment is there in the description. You can download it from there. So we had already done question number 21 in the previous episode, episode number 9. This is episode number 10 of vectors, and today's topic is direction cosines and direction angles of a vector. I have been telling you that every vector which is expressed in terms of I, j and k will have a magnitude as well as a direction. Alright. So let us take up an example. Suppose I have a vector A whose expression is like this. I am just taking a random example from the assignment. This is some vector expressed in terms of I, j and k. Every vector has a magnitude as well as the direction. Magnitude we have been finding past many lectures. So what is magnitude? It is the square root of the sum of, then you take the coefficients of I, j and k and square them. So 3 square, 2 square and minus 3 square, and that you calculate. So we have already done this. Today's topic is not to find the magnitude of the vector. Today's topic is to find the direction of the vectors. So we have to define 3 terms: direction angles, direction cosines and direction ratios. Now what are direction angles? As the name suggests, every vector will make certain angles with x-axis, y-axis and z-axis. And if I know these angles, I know the direction of the vector. Alright. Now suppose this is my vector OA. So it will make some angle with x-axis, say alpha, another angle with y-axis, say beta, and one more angle with z-axis, say gamma. So these will be called direction angles. So direction angles of a vector is alpha, beta and gamma. And what are direction cosines? Direction cosines will be cos of direction angle. So that is cos alpha, cos beta and cos gamma. Now how do I find direction angles or direction cosines? Finding the magnitude of the vector was very simple. You saw it, and we have done 20 numericals on the same. But now the question and the topic of today's class is, how do I find the direction angles? And is it also simple or complicated? So it is also as simple as finding the magnitude of the vector. Now what you have to do is, step 1 is, you have to find the magnitude of the vector. So let's continue with the calculation. 9, 4 and 9. So how much is this? Square root of 22. 9 plus 9, 18, 19, 20, 21, 22. Now if I divide a vector by its own magnitude, so you know what do I get? I get a unit vector along the same direction. So now you divide this vector by square root of 22, which is the magnitude of the vector. So what you have done? You have converted the vector into a unit vector. Now you can separate it out. So 3 by square root of 22 I cap plus 2 by square root of 22 j cap minus 3 by square root of 22 k cap. So what you have done, you have converted the vector into a unit vector by dividing by its own magnitude, and then you separate it out. Now the magic is here. The coefficients of I, j and k are nothing but direction cosines, and we will give them symbols L, M and N. So what is the first direction cosine? 3 by root 22. What is the second direction cosine? Cos beta 2 by square root of 22. And what is the third direction cosine? Minus 3 by square root of 22. So it was perhaps as simple as finding the magnitude of the vector, a couple of lines more. So divide the vector by its own magnitude, separate it out, the coefficients of I, j and k are nothing but the direction cosines. Now if you have to find direction angles, so what will be alpha? This cos will come on this side, so it will be cos inverse 3 by root 22. If this is a familiar number, say 1 by root 2, I could have said alpha is 45 degrees. If cos beta was 1, I could have said beta is 0. If gamma was 0, I could have said gamma is 90 degrees. But these are the numbers about which I just can't do anything. So beta will be what? Cos inverse 2 by root 22, and the third direction angle will be cos inverse minus 3 by root 22. So now you know what are direction angles, what are direction cosines, and how do you find direction cosines. First, direction cosines will be obtained, and from direction cosines you will get direction angles. Now if you take square all three of them, L square, M square, N square. If you square it, what will you get? Tell me. 9 upon 22, 4 upon 22, 9 upon 22. And if you add them, you are going to get a theorem which we are going to use. So let us see. What will be that? L square plus M square plus N square. When you square this term, 3 by root 22, what is M? What is M? 2 by root 22. And what is N? Minus 3 by root 22. So what it will be when you square? 3 square 9, root 22 ka square 22, plus 4 by 22 plus 9 by 22. So when you take LCM, you will get 9 plus 4 plus 9, and that is what? 22 by 22, and that is what. So I get a theorem now which I am going to use. L square plus M square plus N square is always 1. Okay. So now we know what are direction angles, direction cosines, how to find the direction cosines, and a theorem, sum of the squares of the DCs is 1. Now the last topic is, how do I find direction ratios? Now what are direction ratios? As the name suggests, you take the ratio of the direction cosines. Okay. So what was the first direction cosine? 3 by root 22. That is cos alpha, also called L. The next one was 2 by root 22. Here it is. And the last one was minus 3 by root 22. While taking ratios, you can simplify it as 3 is to 2 is to minus 3. So these are your direction ratios. In practice, we normally don't write this ratio symbol. So direction ratio will be 3, 2, minus 3. Alright. So now you know all the three. How to find direction angles, how to find direction cosines, what is the theorem, and how to find the direction ratios. What was the vector which was given? You remember the vector was 3i plus 2j minus 3k. Have a look in your exercise book. This was the vector. Now do you see a relationship between the coefficients of I, j and k and the direction ratios? I think they are same. 3, 3, 2, 2, minus 3, minus 3. So what do you get? If you are given a vector, simply take the coefficients of I, j, k, and they are nothing but your direction ratios. Convert the vector into a unit vector by dividing the vector by its own magnitude. So what did we get once we divided by the magnitude? Now you take the coefficients of I, j and k, you get your direction cosines. So if you just take the coefficients of I, j, k, then they are direction ratios. If you convert the vector into a unit vector, then take the coefficients of I, j, k, they are the direction cosines. Okay, and this is the theorem. So I am going to clean the blackboard now, and that finishes the theory of direction cosines and direction angles. There is a caution here. When you had a two-dimensional vector x axis and y axis here, and this was your vector, say OA, if this angle was alpha and this angle was beta, so what was alpha plus beta? 90 degrees. But in three-dimensional vector, alpha plus beta plus gamma is not equal to 180 degrees. Alpha plus beta is not equal to 90 degrees. So there is no summation relationship between the angles. So if you are given two angles and you have to find the third angle, you will have to use this relationship. Alright. So if you have two-dimensional vector, yes, alpha plus beta is 90. If you know this is 30 degrees, you can say this is 60 degrees. But in three-dimensional vector, you cannot use this kind of relationship. So if two angles are given and you have to find the third angle, we are going to use this theorem. So we do a numerical, and there I will show you if alpha is given, beta is given, how to find gamma. It won't come from this relationship, it will come from this relationship. So be careful that don't get an idea that in two-dimensional vectors, if alpha plus beta is 90, in three-dimensional alpha plus beta plus gamma will be 180 or 360 or 90, nothing like that. So let's continue and finish the last two questions of practice paper 1, that will finish the introduction to vectors. Alright, question number 22, and we call it as practice paper 1. The link of this assignment is given in the description. You can just download from there. If you do not have a download facility, anyway I am writing the questions on the blackboard. You are given two vectors. One is R1, I plus 2j minus k. Another is vector R2, 3i plus j minus 5k. First says you have to find R1 minus R2. Then you have to convert this vector into a unit vector. And then you have to find the direction cosines of R1 minus R2. So let R1 minus R2 be called vector R. So I just gave a name to R1 minus R2. What is R1 minus R2? You can directly subtract. I minus 3i minus 2i plus 2j minus j is plus j minus k plus 5k minus 1 plus 5. How much is that? Minus 1 plus 5 is 4k. Alright. So R1 minus R2 was a matter of few seconds. Now you find the magnitude of this vector. What it will be? You have to take the squares of the coefficients of I, j and k. So what is that? 4 minus 2 ka square 4 plus 1 plus 16, and that's root 21. Now what you are going to do? You are going to divide the vector by its own magnitude. It will convert into a unit vector. So what will be r cap? R cap is actually this. Will be vector r divided by its own magnitude. What was vector r? Minus 2i plus j plus 4k. So vector r was minus 2i plus j plus 4k. You divide it by square root of 21. When you divide by square root of 21, you separate it out. Now take the coefficients of I, j and k of the unit vector and they are your direction cosines. So what are your direction cosines? We write direction cosines in short like that, DC. So first direction cosine, that is L, that is cos alpha, will be minus 2 by root 21. The second direction cosine M, that is cos beta, will be 1 by root 21. And the third direction cosine, that is N, that is cos gamma, will be 4 by root 21. The third direction cosines, cos gamma shall be 4 by root 21. So, and if you take the ratios of DCs, you will get DRs, that will be minus 2 is to 1 is to 4, minus 2 is to 1 is to 4, the coefficients of I, j and k. So, I am hopeful that this question is clear to you. Now you know that every vector expressed in terms of I, j, k obviously has a magnitude as well as direction associated with it. Magnitude also you know how to find. This is how we found the magnitude, and direction ratios also now you know how to find. And from the direction ratios you can find the direction angle. What will be the angle which the vector makes with the x axis? Alpha. Cos inverse in the bracket you write minus 2 by root 21. So let's do the last question of this assignment, and that will finish the basics of the vector. And the next topic we will be doing will be how to multiply two vectors, and that will be covered in the next episode 11. So the last question of this assignment, when you do this complete assignment, I will be giving you 3 assignments, one on the basics which we are just about to finish, second one will be on dot product of vectors, and the third one will be on cross product of vectors, and after that we do some numerical from NCERT, and that is all. You do not need to do anything else. You are well prepared for your board exams. The position vector of 2 points are given. So there is a point A and its position vector is 5A plus J plus K. You know position vector is written below the point in the bracket, and if you know the position vectors, you also know the coordinates of the point. And there is another point B, its position vector is 3I plus 2J plus K, and therefore the coordinates of this point are 3, 2, 1. How do you find the coordinates of this point? Coefficients of I, J and K, 3, 2 and 1. Find the direction cosines of vector AB and show that AB is parallel to XY plane. So look here. So first I will have to make vector AB. So you know the formula of how to make vector AB. We have been doing it in the previous classes. x2 minus x1 I cap, this will be x2, plus y2 minus y1 j cap, plus z2 minus z1 k cap. Now what is x2? 3 minus 5 I cap plus 2 minus 1 j cap plus 1 minus 1 k cap. So that will be minus 2I plus j plus 0k. So now I know what is vector AB. You could have also said OB, that is position vector of B minus OA. That is one in the same thing. Now you are familiar how do you find the direction cosines of a vector. First you will have to convert the vector AB which you have just now made into a unit vector. To convert a vector into a unit vector, you have to first find its magnitude, which is the sum of squares of coefficients of I, J and K. What is the coefficient of I? Minus 2, square it. What is coefficient of J? 1, square it. And what is coefficient of K? 0, you square it. So minus 2 square is 4 plus 1, that will be square root of 5. Now you divide the vector by its own magnitude, you will get a unit vector. So let me write it here. So what will be unit vector? It will be vector AB divided by its own magnitude, and then you can separate it out the way we did in the previous question, like this. No need to write one extra step. Previous question I did write, but here I am writing it directly. 0 by root 5k. What is 0 by root 5? 0 only. So you can just simply write it like this. So what you have done, you have first made a vector AB, because you are not given vector AB, you are given the position vector of A and B. So vector AB is position vector of B minus position vector of A, then you find its magnitude, you divide the vector by its own magnitude and you separate out the terms. The coefficient of I, J and K are nothing but your direction cosines. So what is cos alpha? Minus 2 by root 5. What is cos beta? 1 by root 5. And what is cos gamma? 0. What I was required to find? The direction cosine. So my answer is done. And these are L, M and N. Now there is another rider to this question, which is a little conceptual part. So you can write it down and you can pause your video and write it down, but try to understand now. So if you are in a hurry to write, you can pause your video and write it later. Right now you just listen and try to understand. If you can match the pace of my writing on the blackboard with your writing in the exercise book without compromising on your understanding, then it is okay. Otherwise, more focus should be in understanding, not in writing. You can obviously re-watch the video and then write. So, you know what you have learned in this question. This seems to be a very complete question. You are given 2 points, you learned how to make the vector, you learned how to find the magnitude of the vector, you learned how to convert a vector into a unit vector along the same direction, then you also learned how to find the direction cosines. So this one question in the exam seems to be a very complete question to check the knowledge of a student. Now, let's look at the last part. If cos gamma is 0, what does it imply? Gamma is pi by 2. Because you know, cos 90 degrees is 0 and cos 0 is 1. So gamma is pi by 2. So what does it imply? Vector AB is therefore perpendicular to z axis, because the angle which the vector makes with x axis will be alpha, that will be cos inverse minus 2 by root 5. Beta which the vector makes with y axis will be cos inverse 1 by root 5, and the angle which the vector makes, that is gamma with z axis, is pi by 2. Therefore, your vector AB is perpendicular to z axis. Now what does that imply? If any vector is perpendicular to z axis, it is automatically parallel to xy plane. Now you see, if this is x, okay, and let me write for the sake of understanding y here and z here, alright. So this is xy plane, alright. This is z axis. Your vector AB is now perpendicular to x axis. Let me draw it here. It need not be touching x axis. Anyway, vectors are free to be moved in the space. So this is vector AB. So you can see any line perpendicular to OZ will automatically be parallel to xy plane. If you are sitting in the room, you can take the one edge of your room as x axis, another edge of the room as y axis. Then the floor on which I am standing or you are sitting in your home will be xy plane. And the corner line, vertical line upwards will be your z axis. You can say the hinges of the door. So if anything is perpendicular to the hinge of your door like this, it will be automatically parallel to the floor. So a vector perpendicular to z axis implies it is parallel to xy plane. So that was the last part I had to prove. Therefore AB vector or simply line AB is parallel to xy plane. That's all. So we have done in 10 episodes, approximately 6 hours, the introduction to vectors. So now we are very familiar with the vectors. Rest of the topics are building on what we have already studied. Now in episode number 11, we are going to study how to multiply two vectors. So there are two ways of multiplying vectors. One is called dot product or scalar product, and another is called cross product or vector product. So in episode number 11 we are going to do dot product, and episode number 12, 13 and 14 we are going to do practice paper 2 based on the dot product. So I'll end this lecture here and we'll meet very soon in episode number 11 where we are going to multiply two vectors. Thank you for watching. I hope you understood the lecture well and you will continue to watch further lectures. So this is Sanjay Agarwal signing off for now. Bye.